Hi. In this set of lectures, we're going to talk about problem solving. We're going to talk about how individuals and teams go about solving problems. And we're going to focus on a couple things. We're going to talk about the role that diversity plays in problem solving, and we're also going to talk about how ideas can get recombined and how a lot of innovation actually comes from somebody having one idea in one place and it being applied someplace else. So those are going to be the two main themes, the role of diversity and the power of recombination. So to get there, to think about how we model problem solving, we've got to start out by making it formal, by constructing a somewhat formal model. So here's how we're going to do it. We're going to assume that you take some sort of action, A, or that you have some sort of solution that we'll represent by A, and then there's a payoff function, F, that gives you the value of that particular action. So that action could be, a particular string of code if you're writing computer code, and F might be how fast that code runs, right? Or alternatively, A could be a healthcare policy, and F would be how efficient that healthcare policy is. So A is the solution that you propose, and F of A is how good that solution is. What we want to do is we want some way of understanding how people come up with better solutions, where innovation comes from. So to do that, we're going to invoke a metaphor. And we're going to use this metaphor of a landscape as a lens through which to interpret our models. Okay? So think of it in the following way. You are trying to come up with some sort of solution to a problem, and each solution has a value. So the altitude here is the value of it. So B is the best possible solution. Now along the x-axis, these are all the different solutions. So I might start out by having some idea. Let's just put it right here, and here's my idea. And it's an okay idea, but we'd like to think about how do we find better ideas. Well, one thing we might do is we might sort of try things to the left and to the right and realize and sort of climb uphill here, and we get to some point C. And C might be where I'd get stuck, because if I go to the left, I'm lower, and if I go to the right, I'm lower, so I could say, boy, C's the best thing I can come up with. What we want to see is how people come up with these ideas, how teams of people come up with better ideas, and how we can avoid getting stuck on C and possibly get ourselves up to B. How are we going to do it? Well, here's what the model is going to look like. We're going to start out by talking about something I'm going to call perspectives. What is a perspective? A perspective is how you represent a problem. So if someone poses some problem to you, again, whether it's writing code, healthcare policy, designing a bicycle, or designing an addition to your house, you have some way of representing that problem in your head. That's going to be a perspective. It's literally how you encode the problem. Once you've encoded the problem, what you do is you create, again, this is sort of metaphorically, a landscape. Because I can think of your encoding as like that horizontal axis, and then there's a value, for each possible solution, and that creates a landscape. So we're going to talk about how different perspectives give different landscapes. That's the first part. Second part is something I'm going to call heuristics. Heuristics are how you move on the landscape. So remember when I drew that landscape a minute ago, I talked about climbing up the hill? Well, hill climbing is one heuristic. Random search would be another heuristic, right? You could just sort of randomly pick some points and then find which one has the highest value. That's another heuristic. So we'll talk about how different perspectives and different heuristics allow people to find better or improving solutions to problems. So that's going to be the focus of our model of problem solving. People have perspectives and people have heuristics. Once we finish talking about individuals, then we'll talk about teams. And one of the interesting things here is if you have groups of people or a team of people trying to solve a problem, you actually can show that they'll be better than the individuals in it. And the reason why is because they have more tools, and those tools tend to be diverse. So they have different perspectives and different heuristics, and all that diversity makes them better at coming up with new solutions and better solutions to problems. So teams are going to be important. After we've talked about teams, and after we've talked about the role of how one person can improve upon a solution of another, we're going to sort of extend our model a little bit and talk about recombination. So here's sort of the big idea. The big idea is this. I have some solution from one problem. You have a solution for a different problem. And sometimes I can take your solution and combine it with my solution and come up with something even better. So if you think about sophisticated products like a house, an automobile, or even a computer, that consists of all sorts of solutions to sub-problems. And we're going to see how by recombining solutions to sub-problems, we get ever better solutions, and that's really a big driver of innovation. So let's think back for a second. Remember in our previous lecture we talked about how without sustained innovation we no longer get growth, right? That growth depends on sustained innovation. What we're going to talk about here is how diversity leads to innovations and how recombinations of innovations can lead to even more innovations. So that's the big theme. So that's where we're headed. We're going to start by talking about perspectives, then we'll talk about heuristics, then we'll talk about how teams of people can leverage their diverse perspectives and heuristics, And then we'll talk about how recombining ideas can really drive a lot of growth. All right, let's get started. Thank you.